Learn like a pro.
Hey there, welcome. As someone who's spent years with their hands in the dirt, I can tell you something for sure. The line between a crop that thrives and one that, well, fails often comes down to things you can't even see. So today, we're going to dig deep into the amazing chemistry that turns that dust into the foundation of our food. Let's get into it.
It's a puzzle that every farmer, every gardener has faced at some point. You've done everything right. You've got the water, the sunlight, all the good stuff, but something is just off. And that problem, 9 times out of 10, is hiding right there, under our feet.
So what's going on here? Why does one plant look amazing while its neighbor, just a few feet away, is struggling? The answer usually isn't some pest or disease you can spot with your eyes. Nope. It's a chemical imbalance, a silent stressor that's holding that plant back.
And here it is, the hidden culprit, soil acidity. This can be caused by a bunch of things. Acid rain, even the fertilizers we use to try and help things grow can contribute. Just think of it like this. It's like trying to run a marathon on an empty stomach. The plant just doesn't have the right environment to get the nutrients it needs to really take off.
But here's the good news. A chemical problem has a chemical solution. It's a method that farmers have been using for a long time, and now it's just perfected with a little bit of modern science.
And that solution is called liming. And nope, we're not talking about the little green fruit. Liming is the practice of adding a special substance to the soil specifically to fix that acidity problem and get the pH right back where it needs to be.
So what are we actually doing here? Well, liming is all about adding an alkaline or basic compound to neutralize that acidic soil. Farmers have a few choices. You could use something like slower-acting limestone or regular lime, but for professionals who need results, the top choice is often calcium hydroxide, also known as slaked lime, because it just gets the job done fast.
This whole thing works because of a really fundamental chemical reaction called neutralization. And it's a beautiful concept, really. You take an acid, you take a base, they react, and boom. They basically cancel each other out. What you're left with is a neutral salt and water. And this is the key reaction that saves our crops.
Okay, so to really get why liming works, we've got to zoom in a bit on the chemistry. It all comes down to this big family of compounds called oxides. And if you can understand these, you're on your way to mastering soil science. Classifying an oxide is actually way easier than it sounds if you just follow these steps. First, just look at what's bonded to the oxygen. Is it a metal or a nonmetal? That very first question sends you down one of two paths, and it'll lead you straight to the right answer every time. Now let's focus on the two main players. On one side, you have your acidic oxides. These are made from nonmetals. Think carbon dioxide, the stuff we breathe out. They only react with bases. Then on the other side, you've got your basic oxides, made from metals, like the calcium oxide that's in lime. And what do? You guessed it. They react with acids. This is neutralization in a nutshell. And check this out. This table lays out the whole family perfectly. See our basic oxides in blue? Things like magnesium oxide, they come from metals. Then you've got the acidic ones in red, like sulfur dioxide from nonmetals. And then we have our two special cases, the amphoteric ones in purple, we'll get to those in a second, and the neutral ones in gray, which just don't react at all.
Okay, let's talk about those weird ones, the amphoteric oxides. I love these. They're like the chameleons of the chemical world. Take zinc oxide, for example. If you put it in an acid, like hydrochloric acid, it says, okay, I'll be a base. But if you put it in a base, like sodium hydroxide, it completely flips its script and acts like an acid. It can literally play for both teams.
And then you've got the neutral oxides. The best way to think about them, they're like the neutral party in a debate. Compounds like water or carbon monoxide, they just don't react with acids or bases. They just stay out of the argument completely.
All right, let's bring this science back to the field, because applying this knowledge the right way is absolutely critical. There's one big mistake a farmer can make that wastes time, money, and some really valuable resources.
So here it is, the one thing you absolutely have to remember. Never, and I mean never, mix your lime, which is a base, with any ammonium-based fertilizers. This is one of the first things you learn in agricultural science, and trust me, it's for a very, very good reason.
So why not? Well, it all comes down to a reaction called displacement. When that basic lime gets together with the ammonium salt in the fertilizer, it chemically bullies the ammonia and forces it out as a gas. That ammonia gas is full of the nitrogen your plants need, and instead of going into the soil, it just poof, vanishes into the air. You're literally letting your most valuable nutrient just float away.
All right, that was a lot of information. You think you got it? Let's do a quick check to see if it's all sticky. Ready?
First question. You have a metal oxide. It reacts with an acid, and it reacts with a base. What do we call that type of oxide? Think back to our little chemical chameleon.
If you said amphoteric, you are spot on. That's the one. Remember, amphi kind of means both, just like an amphibian lives on both land and water. This oxide reacts with both acids and bases.
Okay, next one. You're out in the field. You add your basic lime to your acidic soil to get that pH right. What is the name of that all-important chemical reaction?
That's neutralization. It's the powerful, crucial reaction that makes healthy soil and really happy plants possible.
Okay, this right here is the perfect summary to lock all this in. You might even want to grab a screenshot. It lays out the general rules so simply. Metals usually form basic or amphoteric oxides, while nonmetals tend to form acidic or neutral ones. And it recaps exactly how each one behaves. This is your ultimate cheat sheet for oxide properties. So, I'll leave you with this thought. The next time you're driving past a beautiful, vibrant field of crops, or maybe just admiring a healthy garden, just take a second and think about all the complex, totally invisible chemistry that's happening right there under the surface, turning simple dust into dinner. Happy growing!